Hi, my name's Denisan.
My name is Kamran. We are co-op students from Rick Hansen Secondary School. Today we are working with Studica systems, testing out 2 products from Fischertechnik. Over here we have the ball obstacle course with the vacuum arm. Over here we have a pinball machine, and further down the room we have a Robo Explorer, which we will get to later on. Let's start off with the ball obstacle course.
So this is the roller coaster I sort of built with the vacuum arm. So basically, what happens is I drop the ball, and both these lights are on. And when the lights are on, you'll notice that there's no light being emitted to the other side, to the photo transistor. So it will know that the ball is exactly at that location, and it'll drop the arm, suck the ball up, and bring it back up here. Some problems that I noticed with this were that first of all, the vacuum arm was hitting hard on the ball, hitting too hard on the ball, and this basically made it so when we wanted to suck up the ball, it would push it out of the way, and there's no point of not being able to pick up the ball. Also, what we also noticed was there's not enough suction given so the ball can be picked up. And what we did to try fixing that is we tried putting 4 pneumatic pumps, and since that didn't work, we just decided to run the program without picking up the ball. And now we will go into Kamran and his pinball machine.
So over here we have the pinball machine, something that everyone should be very familiar with. As I'm setting it up, let me make you aware of some common parts that you should be aware of. Over here we have our flippers. We have our pneumatic pistons here and here. We have 2 switches and the air compressor. And of course the microcontroller, let's not forget it. This is where all the programming is held. Now, in terms of how the system works, these 2 switches would send a signal to the microcontroller, which in turn gets the air compressor to flow the air through these valves to the pneumatic pistons. As you can see, it acts based on my switches. The pinball machine works very similar to any other pinball machine you've ever seen before. You basically drop the ball in and just have a good game until you lose, like right now. What else? Over here we have another sensor. What this does is, as the ball passes, if you have the program set to do so, it will add about as many points as you want it to do within the program. Over here also we have a photo transistor sensor. What happens is, as the ball falls through, it's going to block the light from the LED to the sensor, letting the system know that the ball has fallen through and that the player has lost the game. This will reset, according to my program, this will reset the game for about 5 seconds and start it up again. And that's all you need to know for the pinball machine. Next up, we will be talking about the Robo Explorer. See, this is the obstacle course mat. We have the various objects, such as this is the objective spot, it's purple. This brown spot over here is known as the mountain. It's the obstacle that the robot is to avoid at all times. Over here we have the big peach blob, if you want to call it. This is where the robot should go at 70% more power. And over here it has a power reduction of 25%. And this is the final objective where the mission has been completed. So this is the Robo Explorer. As you can see, it has a tank tread drive. Over here, once again, as with most of the computing level Fischertechnik products, we have the microcontroller to which all of the connections are made. The ultrasonic distance sensor right here is what actually detects the distance from the robot, the current position of the robot, to the different boundaries within the mat, around the mat. As you can see over here, we have our 2 motors over here. This also connects back to the microcontroller. We have the line sensor and the color sensor, which, however, in our program we did not use. This motor connects to these gears, which connected to the front drive as well as the back drive, allowing for the robot to drive in a tank style drive. Over here you'll notice I have a battery. This isn't actually where the battery goes. The battery essentially goes here, but because this was weak and I decided not to switch it out, we just have it over here. There are different places within the microcontroller to add things. We have another sensor here and an LED display here, also which we did not use. And that's about it. That is the Fischertechnik Robo Explorer. Now you've seen the hardware aspect of this robot, but there was quite a bit of programming that had to be done. So to tell you about the programming, we have Denisan.
My name's Hansen, and the program that we use to program the Robo Explorer is Robo Pro. This is what we use to program the pinball machine and also the ball roller coaster. In this program you can see how we just move the left and right motors to turn the robot and move it towards its next destination or checkpoint. What also we have here are a lot of conditions that need to be met with the ultrasonic sensor, which is the I3s. Every condition, basically we want to check for the distance that the Robo Explorer has traveled. To check that, we pre-measure our distances before we actually put it into the program. So we use what we call the interface test, or test interface. Right now, since the robot is not connected, we can't check it, but normally we would have our robot connected. We would check around the barriers and check the distance that is between the barrier and the checkpoint. In this program you can see how also we have a lot of delays. We use these delays because sometimes the distance cannot be it could be same at two different angles, so the back and the front. And to do this, we just add a little 1 second, 2 second delay just to make sure that we turn it in the right direction we want to.
So these, as you can see, are the few products that we've been working on for the past week here at Studica Systems. Once again, we have the ball obstacle course, we have our pinball machine, and of course the Robo Explorer. We've learned a lot this past week using these various models. For example, with the Robo Explorer over here, we've learned that you can use sensors, microcontrollers, and programming software to control a robot such as this.
Right, and I learned that we can use electricity and pneumatics to control the solenoids and push air to create a vacuum for the vacuum arm. And on the pinball, we learned that we can use solenoids to push air to control the pistons to go up and down.
Well, these are the awesome products that we've been working with here at Studica Systems, but also don't forget that Fischertechnik does have plenty of other products. If you wish to check out any of these products, go to www.studica.com.